Good morning, everyone. Welcome to question number 3 of the One Concept Per Day portal. And this is my third question that we are solving today. And previously to this, we had solved two problems. Okay, these were related against electrical circuits. The concept today that we are discussing is about electrical circuits. And here we had learned about how to draw the diagram for an IV circuit diagram, IV characteristics. And then we also learned about okay, so a similar question was asked over here to find out, okay, when will the voltage, when will the current actually pass through it, and so on. And then we have also learned about how to analyze the circuit, how to draw the IV characteristics. Anyway, so whole paper is now devoted only towards the IV characteristics. Okay, now let us look at this question. This question is taken from May 2006 paper, TZ2. And this question, I find it to be very much interesting. There are a lot of concepts, sub-concepts which are being covered over here. Please watch it until the end and you will get to know how complex the problems in IB can be asked. Okay, there's a lot of details that you need to look into in the graphical answers. Okay, now let us understand this. So the question states, the diagram below shows the circuit used to measure the IV characteristics from an electrical component X. Okay, so this is over here. So on the diagram above, label the ammeter A and the voltmeter B. Okay, so ammeter A, ammeter is connected here, voltmeter is connected here because voltmeter should be in parallel to the X. Mark the position of the contact of the potentiometer. Contact of the potentiometer. This is your potentiometer. This is a slider over here. Okay, that will produce a reading of 0 on the voltmeter. Okay, where should you place the slider so that you get a voltage equal to 0? Okay, now you see the slider can be placed here, it can be placed here, it can be placed here, anywhere on the line over here. Okay, it can't go outside. Now first understand, let us look at the circuit here. A current I is being delivered over here. So the current comes like this, it comes like this over here. It comes here and then it branches over here. Okay, it branches over here. Now let me assume that this slider is being kept over here. It's being kept at this position. When it is kept at this position, what will happen? The current will come here, zero resistance here. Okay, so here what is it? Now here you see more resistance because definitely more resistance. So as compared to this particular line, so what will do? The current will not enter here. Current will come here, then it will go like this. It will go to the ammeter, then it will go here, then it will produce I into X over here, I into R, whatever it is. Voltmeter might read a current over here. But the moment it comes over here, now what should happen? Will it come like this? That's the first question we need to ask. Okay, so part of this current, not all current, part of this current. See, the current will flow only when there is a difference in potential. See, what is the potential at this point and this point? Is there a potential difference over here? There is no potential here, right? So as a result of it, when it comes over here, when it comes at this point, it observes, okay, the potential at this point, let me call point as some P, and this point Q, they are all one and the same. If there is same, then definitely current will not flow here, right? The current will not go through the circuit, but instead it will just goes like this, which means the current through this X would be 0 here. Current through this X would be 0 here. But on the other hand, let me say for example, I'll discuss the second part also. Okay, let us say this is your P1. If I put the point P2 here and I take the slider and connect it here, then current will come here. Then when it comes here, it observes there is a path like this, there is also a path like this. Okay, so as a result of this, now it can go like this. Okay, now you see this point and this point, there is definitely a potential difference between these two. Okay, and as a result of it, definitely there will be some amount of current which can pass through. So thus P1 could be the right answer. Okay, thus the answer here should be, the point should be at the bottom. You can say point is at the bottom. Point is at the bottom. Or maybe you can just write the position of P. Okay, next. The graph below shows the current voltage characteristics of two conductors X and Y. X and Y is being shown. State the current value of the current for which the resistance of X is the same as the resistance of Y and determine the value of the resistance. What is being asked? You had to find out what is the value of, the value of current, okay, for which Rx is equal to Ry. That's what we need to find. Now what we have here, how do we find it out? So if you want Rx to be equal to Ry, what do we need? We need the same voltage and same current. Okay, both of them should be the same, right? Because Rx is determined by Rx equal to Vx by Ix and Ix, and Ry is determined by Vy divided by Vy divided by Iy. Okay. So either the ratio should be the same or it should be similar. Okay. Now towards it, now what we'll do is, let us find out where is this possible. If you look at this here, at this point, you see this curve branches and meets at this point. This straight line also branches and meets at this point over here. What is the value of I and V here? The value of V here is 10 volt and the value of I here is going to be 0.4 amperes, right? So therefore you observe that V and I are same for the intersection point over here. So what I will do is, I will write here the current at which the resistances are equal is going to be 0.4 amperes and the resistance R will be equal to V divided by I. What's the value of V? V is equal to 10 volt. This will be 10 divided by 0.4, which will be equal to 100 divided by 4, which is equal to 25 ohms. Okay, the resistance at that point is going to be 25 ohms. Now, describe and suggest an explanation for the IV characteristics of conductor Y. These are 3 marks. So you need to understand what's going on here for the IV characteristics. Now, in the X, if you see, when you increase the voltage, current also increases proportionately. This is obeying Ohm's law. Now, this is not obeying Ohm's law. It's non-linear. Now, let us understand how does it happen. For V equal to 1 volt, current equal to how much? Current is around 0.05, 0.07, 0.08 over here. Okay, let me write down if you want. 0.08. When the voltage is doubled, then you see what is the current over here. Current is seen to be 0.15, 0.16, 0.17 over here. 0.17 over here. When the voltage is tripled, then what will happen? See here, you see that the voltage is seen to be 0.20, 0.24, right? So if I do it like this, see in this region, if I look at this region over here, maybe I can consider until here. Until this region, I see this V is proportional to I. It obeys Ohm's law. Okay, V is proportional to I until V is equal to 2 volt. Okay, so what I can write here is that I can write at first mark, at lower voltages, I is proportional to V, or Y obeys Ohm's law. We can mention this because we are observing something from the graph, right? So we can mention this. Then the second part, if you look at this here, now what's happening over here? There's a non-linearity been observed. Now for every rise in voltage, now I make it 3 to 4, 1 volt if I increase over here. Look at the current here. Current is not increasing so much because you see this 0.25, this 0.24, this 0.25, so this 0.23 here, 0.23 here. This will be 0.25, this is 0.2727. For an increase of 1 volt, what is the increase in volt current? Current is 0.04 here. How much was it here? It was 0.08 volt, right? So therefore you can say second one, beyond what is the voltage over here? Beyond 2 volts, for increase in voltage, current increases slowly. That's what you can say. And is non-linear. So we have already put 2 points over here. Now let us look at the next point over here. The third point we can put. We have explained the IV characteristics. We have put the IV characteristics over here. So no need to compare once more what's happening over here. Don't put this one here. Now, when the voltage is still increasing, current keeps on decreasing. Now, why can this happen? Now, at higher voltages, I starts reducing. Why does it happen? This we have seen in case of a lamp also. Why does it happen? The reason is maybe at higher voltages, temperature is higher, resistance is higher, current drops down, right? So we are now able to comment on what is happening to the resistances also. Okay. So this has been observed. If you want, you can write one more line and say this is observed. This is observed by taking the slope. By taking the slope at higher voltages. At higher voltages. So what happens to slope? Because we are just looking at higher voltages. What happens to slope? See here. So at higher voltages like this, for example, if I take the slope here, what's happening? This angle with respect to this one is reducing. Here it was larger, right? If I take the horizontal over here, this was larger. This was much larger. And here you see, this is much smaller, which means the slope is reducing. Tan theta is reducing. So tan alpha was larger, tan theta is reducing. When the slope reduces, what is slope here? Delta I divided by delta V. Okay, when slope reduces, then 1 by slope increases. What is 1 by slope? Which should be delta V divided by delta I. I take the reciprocal of this one, right? Which is nothing but resistance. Okay, that's what is being evident from the graph also. Okay, now we have written all this by taking the slope at higher voltages, which implies larger value of the resistance. Okay, next. Two conductors X and Y are connected in the circuit as shown below. The same graph that we have put it over here. Okay. The cell has EMF 12 volt. Okay. A negligible internal resistance, the resistance Z has a resistance R, and the PD across the conductors X and Y is 5 volt. PD across this point is seen to be 5 volt. Okay. Now, when things like this is given, one thing that you should understand here is that if this is 5 volt, this should be 7 volt. Okay, immediately you can make it out because these are all resistance, right? So this is one fragment is given to you, the other fragment you can easily find out. Okay, he has not asked you, but let us see how to solve it. Then use the graph in figure B to determine the total current in the circuit. Oh my god, to find the total current. Okay, so now what we do is we'll go back to the graph, total current. Now you see the total current I here will now be equal to Ix plus Iy. Okay, now with this information, let me go back to the graph and see, and I have I is equal to Ix plus Iy in such a way that the potential difference across this is Vx equal to Vy equal to 5 volt. Okay, so let me write down that also, that Vx is equal to Vy is equal to 5 volt. This is what we have. I think this is too much clumsier. I'll just erase this off so that I can write it out much more clear over here. I'll remove this all because I already done this. I don't want all these details over here. Okay. Now what do we have here? Okay, this also. Okay, now we have this much, and now what do we do? When Vx equal to Vy equal to 5 volt. You see, this is common Vx equal to Vy equal to 5 volt. If I take Vx equal to Vy equal to 5 volt, where is it? It's at this point. At this point. What is this V here? Let us read the question once again. IV characteristics of the current voltage characteristics is given over here. So, at V is equal to 5 volt over here, V equal to 5 volt, drop a vertical line like this. If I draw a vertical line like this, I will get some value here. What is this value here? This is the current value for the X conductor. You get the value of Ix. How much is the value of Ix? This is equal to 0.2 ampere. Now at this point, you see, this is the current on the Y conductor. So the current here is Iy is equal to, what is its value? 0.3 amperes. Now what do I say? The total current I is equal to this current plus this current. So the total current I is equal to 0.2 plus 0.3, which should now be equal to 0.5 amperes. What I will do is I will once again go back here and I will write, using the graph I have found out that I is equal to 0.5 amperes. Okay, this is not an easy question. So these kinds of questions are mostly asked. So you should know how to analyze it using graph. If you did not understand, you can put down in the comment section. I'll be happy to answer this. Then determine the resistance R of the resistor Z. Now what's happening here? We have got the current. The current here is 0.5 5 ampere. Current I is 0.5 ampere. The same current passes here also, right? When it passes like this over here, then what's happening? This voltage here is already 7 volt, which you already know. Okay, we found out this because total was 12. This 5 volt is getting dropped over here. The rest 7 should get dropped over here, right? So therefore, I want to find what is the resistance over here. So therefore, how do I do? I can do it like this. I can say 0.5 times Rz is equal to 7. I can do like this. So Rz should be equal to 7 divided by 0.5. So what is this now? This should be equal to 14 volts, right? R should be equal to 14 ohms. So the value of the resistance, determine the resistance R of the resistor, which should be equal to 14 volts. You got this also. Determine the total resistance of the parallel combination of X and Y. I need to find out what is the parallel combination of X and Y. So what I will do is, let me write down this full resistance to be Rp. Rp. This is what I need to find. Okay. So now what I will do, okay. Now we know a current of, how much current is coming out here? 0.5 amperes. A current of I is equal to 0.5 amperes is coming out from the circuit, provided this resistance, okay. Now what I will do is, I is equal to 0.5 amperes. Now in this case, I will do something like this. I will write I multiplied by, what is this resistance? This resistance 14 ohm, plus whatever is the resistance of this, I do not know what is that value. I'll write this Rp should now be equal to 12 volt. Can I write like this? I can always write, right? Okay, the reason is because I see the total voltage is equal to so much. Okay, now what is I? 0.5. 0.5 into 14 plus Rp is equal to 12, or 14 plus Rp is equal to 24. Rp is equal to 24 minus 14, which should now be equal to 10 ohms. Thus, this resistance Rp should be equal to 10 ohms. Let me see my analysis before we stop. Yes, Rp is equal to 10 ohms. Okay. So thus, we have solved all these questions. So each question is really a gem, that's what I can say, because it gives you a lot of information about how to solve such kinds of questions. Okay. So with this, let me come to an end to this part, and let me continue with the fourth problem in the next video. Thank you.